This class we will just discuss about the syllabus and some of the softwares you need to install in your system. So let's open the syllabus first and discuss. So if you go to your Teams and if you look at files, if you click on files, you will see 3 folders. All the lectures will be posted. I will post, for example, here in the class materials. Okay. And the syllabus and design project, these are the two other folders. In syllabus, you will have the syllabus, and we will also have a design project, which we will try to discuss this particular class. Okay. So I'm going to open the syllabus now. Click here and you have the syllabus. Let me zoom in. Make it a little bigger. Okay. So what is this course about? This is about design of mechanical elements. Mostly you will be recalling what you have learned in solid mechanics. And it is very much essential that you have to know all the methods which you have used in solid mechanics and also statics. So these two courses are very important with respect to this particular course. So please try to recall all the methods you have learned. For example, how to draw the free body diagram in case of statics, how to draw the free body diagram, how to draw the shear force and bending moment diagrams. These are very important prerequisites for this course. And you also need to know how to calculate stresses, bending stresses, tensile stresses or compressive stresses, torsional stresses, etc. Okay, so these are all prerequisites for this course. There are 2 sections I teach, and each of this section is on Sunday, Tuesday, and Thursday. Okay, on Sunday, Tuesday, and Thursday, we have the lab hours for this particular section between 8 to 8:50. Okay, so we will be utilizing both the lab hours and the lecture hours both together because we have quite a lot of material to be covered. So during the lab hours, we will also see how to use ANSYS. What is ANSYS? I will introduce that later. It is a finite element software where you can create models and do stress analysis. Okay, so we will be learning a very basic part of the ANSYS, and you will be using ANSYS in your project work. Okay. Now on Tuesday and Thursday, we have the usual lecture hours 9 to 9:50 and also the lab hours 8 to 8:50. Okay, so on all the 3 days, I will be utilizing the lab hours unless we are near completion of the course. Unfortunately, we have to utilize the time because there is too much material to cover. There is another section which is between the lab hours are between 11 and 11:50 and 12 and 12:50 is the lecture hours. So these are the 2 sections. The textbook which we will be following is Mechanical Engineering Design by Shigley. Okay, 10th edition. You may use the 11th edition if you want. Also, all these editions, there is slight difference between 10th and 11th edition. Maybe 11th edition has much more material than the 10th edition. You can additionally use other reference books. If you have them, you can use it. Otherwise, you need not worry. Okay. So what are the softwares we will be using? As I told you, mostly we will be using ANSYS. Okay. So ANSYS. So that is the software package. I will also introduce to you what is called a CES EDU pack, which is a software. Unfortunately, it is not available for free. I will just show you how the software works for material selection. Once we go through chapter 2, we will discuss about this software as well. Okay. So let's go to the course assessment. With respect to the course assessment, as usual, we will have 2 midterms. Okay, so here this is the test or midterms. One of the midterms will be definitely held on campus, and it is worth 15%. The other midterm, depending upon the situation, we will decide whether to have the test on campus or online. Okay, so I cannot promise you whether it's going to be on campus or online for the second midterm. We will see how it works out, and in future you might have on campus or online the second midterm, 15%. We will try to have some quizzes as time permits. We will also have some assignments. I might give you some assignments, for example, group assignments, where you will work with your ANSYS software and you will try to solve some problem. In addition to that, you might also have individual assignments depending upon the chapters we are covering. We also have a project. The project is going to be a group project. 3 to 4 students will join together and complete the project. The project will consist of some design and some analysis, finite elements, using finite element software analysis, or even hand manual calculations which you will do with your hand using formulas. Okay, so you will have a combination where this project, which will be, it will be a comprehensive project. Whatever you have learned in this particular course, you will apply in the project and produce a report as a group. And finally, you will make a presentation, recorded presentation, and send it to me. Okay, so this is worth 20%, and final exam is 40%. Okay. So what is this course about? There are broadly 2 different stages you will study this course. The first stage, in the first stage, you will study what is the theory behind the design equations. Once you study the theory, then you will go for application of the theory to particular machine elements. So in the first part, you can see here, it is all going to be theory, starting from introduction here, all the way going to fatigue failure theory. Okay. So in the theory part, what do we study? In the introduction part, you will study briefly about the design process, what are the design standards, etc. So you will go through some theoretical part here with respect to your design, how to do your design. In theory, additionally, we will have to recall whatever we have learned in your materials science or materials engineering course in the second year. You will have to recall all what you have learned there. In the third chapter, we will be briefly going through all the chapters what you have learned in your mechanics of materials coursework. So first chapter is something new. Second chapter is already what you know. Third chapter is also what you know. Again, new information you will learn in fourth chapter. In fourth chapter, we will be going through static failure theories. So what is static failure theory? Anything that does not vary with respect to time, especially if you have stresses within the material which are not varying with respect to time, then it is a static problem. So whatever you have learned in statics and mechanics of solids, it is completely based upon static theory. So here you will learn about static failure theory, and then we will go for fatigue failure theory or dynamic failure theory. Here the stresses are going to vary with respect to time, and we are going to see how varying stresses with respect to time cause failure in the material. Okay, so failure is going to be a major part in your design uh, course here. Okay, so once you have studied the static failure theory and the fatigue failure theory, you are going to apply these two theories for each of the elements. Some of the applications you are going to see is shaft design and components, also shaft components design as well. You will apply static failure theory and fatigue failure theory for shafts. You will also go through fasteners, screws and fasteners. Okay, and these are called as non-permanent joints. And we will again apply the static and the dynamic failure theory for screws and fasteners. And finally, we will apply the same thing for springs. So these are the three applications we are going to see in this particular course. Any doubt up till now? If you don't have any, yeah, go ahead. Okay, so if you do not have any doubt, we will continue now. So week-wise, what we will be covering, that is given here. Okay, we will try to keep up with the schedule given here. If we are not able to do that, we may take more time to cover those particular chapters. Okay. All right. So first, I'm going to go through the design project as well, so that you will have enough time to form your groups and start your design project as soon as possible. Okay, so what is the design project is going to be in your course? I would suggest you guys to start forming groups, 3 to 4 students maximum. Okay, so maximum number of students in a group is going to be 4 students. And what is the design project? So this is a typical connecting rod. What is a connecting rod? Connecting rod is one of the parts in your IC engine system or power system. If you take your IC engine, the piston will be connected at one end here in this particular end, and your crankshaft will be connected at the other end here. So you can see in this particular picture, you can see the piston. What is a piston? Piston goes inside your IC engine. Okay, and the piston will reciprocate within the IC engine, will go up and down. As the piston reciprocates, the connecting rod, which is this end, will be connected to one of the crankshaft, and the crankshaft will rotate. So this is how power transmission is achieved. The reciprocating motion of your piston is converted into rotary motion of your crankshaft. Again, if you don't know what is a crankshaft, let's try to take a look at it. So this is a typical crankshaft which you will see in your automobiles. So the other end of the connecting rod will be connected here. Maybe. Okay. So when the connecting rod reciprocates, this crankshaft will rotate and transmit power through these gears to your differential, to your wheels of your vehicle. Okay, so again, this picture shows you here. You can see the piston. You can see this connecting rod right here. Let me open it up, a bigger picture. Okay, so you can see here, this is the connecting rod, which we have seen right here, this particular part. So as the piston here inside the cylinder goes, reciprocates up and down, the connecting rod will transmit all the motion onto your crank shaft. Here you can see a flywheel. So the crankshaft will rotate and then transmit power wherever it is necessary. Okay. So when the crankshaft is operating and the piston is operating, forces are transmitted at this end and at this end, leaving your connecting rod to be subject to stresses. Okay, and the connecting rod is also under motion. So what is your project going to be? You are going to design this connecting rod. Okay, you will assume appropriate forces acting on the connecting rod. First, you will do a literature survey and figure out what kind of forces act on the connecting rod. Once you identify the forces acting on the connecting rod, then you will have to design the entire part. So how do you proceed about this project? There are guidelines given here. Each group will produce a report. Weekly, you will record what you have done as a group. Okay, you will produce this record on a final report. So you will produce, for example, what is called as Gantt chart. Okay, what is this Gantt chart? On weekly basis, what you have covered, which part of the particular work you have done, that part will be written. In that particular week, you have covered that particular part of your work or task. Okay, work or task, whatever was completed, that you will put it on a timetable or on an Excel sheet, what you have covered. So read through this. When you read through this, you will understand that each person, whatever role you are covering. For example, if you have 4 students, one of the students will act as discussion facilitator in a particular meeting. Another person will be guiding the entire group as a leader. Another person will organize all the events and tasks which is to be done by each person in the group, etc. Okay, so you will record all these events. Now, what are the tasks to be completed? A brief description is given here. We will discuss this again later also. For now, I'm going to go briefly through this tasks. Design specification. For example, if you take a look at the connecting rod, you will have to do some literature survey on a typical IC engine system in a automobile. For example, if you take your cars, you will have to identify what is the typical length of the connecting rod, what is the typical cross-sectional area, what kind of materials are used, etc. You can identify here. Okay, so all these specifications, they need to be given in design specification. So you will have to give size specification. What are the loads acting on, typical loads acting on the connecting rod, load specification, material specification, any manufacturing methods used to produce these connecting rod, what are the failure modes in any design problem. You will have to identify what are the different kinds of failure that can happen in the connecting rod. You will do a literature survey and typical cost analysis for producing this part. So these are design specifications. All these specifications you will have to produce on a design report. 10% score for this. Design constraints. For example, again, what are constraints? These are limits within which you have to work. If you take your automobile system, the length of the connecting rod will be limited to a certain length. You cannot go beyond the length according to the design requirements in your automobile. So you will have to write down what are the design constraints with respect to length. Okay, similarly, cross-sectional area, you may have some design constraints. What is the maximum area you can have, etc. So all these design constraints must be there. There may be material constraints. There may be manufacturing constraints. Okay, you cannot use any manufacturing method you can want. You cannot use any material you want. For example, you would most probably want ductile materials to be used. So all these constraints must be clearly specified here in this particular section, and this will again go into your report. For each part, I have given you what is the percentage of marks which are involved. Kinematic and kinetic analysis. What is kinematic analysis? Motion. Okay, what kind of motion does the part undergo? And because of this motion, you will have forces acting on the system, and that becomes kinetic analysis. Okay, we have seen, so let me, we have seen here the piston goes up and down, and this particular crankshaft will also rotate. Depending upon the angle of rotation of this crankshaft, the forces acting on this connecting rod will be different. Force may be higher at certain position, force may be lower at another position. So for example, in this horizontal position, okay, forces may be different. Okay, it could be that these are tensile loads acting on the connecting rod or compressive loads acting on the connecting rod. So you will have to figure out what kind of forces act in different angles of rotation of the crankshaft. So this is going to be your kinematic and kinetic analysis going together for your connecting rod. So you will do that here. You will represent any free body diagrams, any force diagrams, shear force, bending moment diagrams, etc. All you will represent in this particular section. Then you have stress analysis. Once you have identified forces, we will have to calculate stresses. In your solid mechanics course, you had different problems. For example, from bending moment, you will have calculate bending stresses. If it is compressive load, you will calculate compressive stresses, etc. If it is tensile stresses, etc. So you will do all manual calculations using those formulas. So you will do all the calculations by your hand, and you will produce a report here. So this part carries 10 marks. So in this part, there are very important steps. For example, you will have to identify what are the critical locations on the connecting rod, where the stresses are highest. You will have to identify. Example, if you look at the geometry of the connecting rod here, there is a hole here. Most probably the stresses are going to be high wherever there is a hole, on this end and on that end. So you will have to identify what are the critical locations and what are the particular stress values there. You will have to calculate it and produce it in the report. You will also have a dynamic analysis. Since the connecting rod is rotating and moving around, if possible, you will do dynamic analysis. Okay. And there is also fatigue failure analysis, which you will have to do. We will learn about this as we go into future chapters. And again, you will produce a report. Finally, you will use your ANSYS system. We will also go through ANSYS software and how to use them. And you will again produce a report using your finite element software. Okay. So let's see here. For example, in your finite element software, you can produce what is the stress distribution Here in this particular paper, you are provided what are the stress distributions. Here you can see very high stresses in this connecting rod near the hole. Okay. In that way, you can also use ANSYS system to produce your finite element software results. Okay, so within the finite element software results, there is some additional material which you can cover, and that will be under bonus points. So there is something called as shape optimization. What is shape optimization? You will change the shape of your connecting rod depending upon the software. What the software will calculate and produce you a optimum shape for your connecting rod depending upon what is the stress distribution. We will go through that later if time permits. We will go through that how to use this particular module in your finite element software. We will go through that. Also, additionally, if you do buckling analysis for your connecting rod, that will also be considered as bonus points. Okay. So once you are done with the finite element analysis, you will also need to do some kind of material selection process. In chapter 2, we will be using Ashby's charts to select the ideal material for your particular design. Okay, so we will see how to use these Ashby's charts. I will also introduce to you a software which is called a CES EDU pack, using which you will be able to select the materials. Okay. Final part of your design will be detailed design and concluding remarks. In detailed design, you will produce all the 2D and 3D drawings. And concluding remarks, you will briefly describe what you have learned in this project and what future recommendations you give. For example, what are the possible improvements in design that could be done? That also could be covered here. Okay. In addition to this, after you produce the report, you will give a 15-minute video presentation, recorded video presentation, where all your group members will present different parts using a PowerPoint there. Okay, you will briefly explain what you have done in your entire project and then submit it. Okay, so this is with regard to the design project. Why do I give you this information at this early point? So that you will have enough time for you guys to form your group and make a presentation before the deadline. When is the deadline? The deadline is going to be, it's not going to be 30th May, 30th April. I'm going to change this. It is going to be 30th April. You have 3 months to finish the entire project. Okay. So after I modify the deadline, I will reload this part. In addition, you have other files here in your design project. You will attach this particular file along with your report here, okay, where you will include your name, IDs, etc. here along with the section. You can form your group with your own section or the other section also. Okay, there are 2 sections and you can form your groups with the other section if you prefer it. The total marks is going to be for 100, and then I will convert it into 20% when you add it to the final score. So the distribution of marks are given here. Again, shape optimization and buckling analysis. If you do, you will get additional 10 marks. And if I am satisfied with this part, I might even increase the score here. So you will attach this part with your final report. There is also a peer evaluation form where each student will fill this form. He will evaluate his group members, how well they have done. So the entire group must cooperate with each other, and each person has to do his part properly. If you don't do it, again, you can note down if the particular member has done his work or not. Each group member will also fill this part, what he has done. He has to clearly specify what is his contribution in the project, and then individually you will submit this peer evaluation report. Okay. So we are done with this project part. Any doubt up till this now? Up till this part?
Doctor.
Yeah.
So all the groups are required to do and work on the same project, which is connecting roads?
Yes, all the groups. All the
And
group.
what about the evaluation? We should include them in the reports?
The individual peer evaluation, you will submit it individually through Teams. Okay, so I will create a space where you can submit your reports individually, but your peer evaluation will be submitted individually, but the group report will be submitted by the leader of the group. Okay, one person will submit the entire report. Is it clear?
Yes, doctor, thank you.
Okay, so I would suggest that you immediately start forming the group. You have 3 months time up till 30th of April, and you should be able to complete the project with this amount of time. Okay. If you don't have any other doubt, I'm going to start with the first chapter. So let's see here. So let's go to the chapter 1. Okay. So chapter 1 is going to introduce you to the basic concepts with respect to mechanical design. Here we are not going to go through calculations, but we will go through the procedure of design. Any design process must have set of steps that you have to go through properly so that you can control your design. Okay, so that is what you are going to learn with respect to this chapter. Okay, so I'm going to skip all this we have covered. So let's start directly with design. What is design? What is a design process? That's what we are going to trying to learn here. So what does a design process consist of? If you take a look at the pictures here, you have some machines. The machines can be very complicated. For example, if you take this excavator, you have different parts to this excavator and they have to be put together. Typically, the number of parts involved in an excavator or an automobile, for example, if you take these automobiles, you will have million parts, 1 million parts, that is 10 power 6 million parts or more. If you take a helicopter, again, you may have million parts. So when I say parts, the parts may include as simple as a screw or a fastener, or it could include a complicated part such as your internal combustion engine. Okay, and you have to put them together. You have to bring all these parts together. How would you do that? Since you have million parts here, all these parts have to fit together. Definitely not it is not just one person working here. You will have different departments. You will have thousands of people working together, and all of them have to do their work in such a way that all these parts they come together. How will they achieve that? There should be a process. There should be a timeline, and there should be a process where they can put all these parts together, and they should be able to do the design. If it is a very simple product, such as your Coke bottle here, the design of this Coke bottle will be very simple, because you do not have any moving part here. All you need to do is simple structural analysis, and probably you will have to decide what is the material we can use to build this Coke bottle. However, if you look at the manufacturing part of your Coke bottle, again, you will have to think about different manufacturing methods. You will have to think about cost analysis, etc. So even a simple part like a Coke bottle will involve huge investments, because you will have to invest in manufacturing equipment, and you will have to decide what is the volume of production, how we can economize and obtain maximum profit, even for this production of a simple part like a Coke can. Okay, so design will involve many complicated steps, not just the stress analysis, force analysis, etc. We will also need to go outside the engineering part, and maybe we need to study about cost, we need to study about material availability, etc. Okay, so first we will try to define what is a machine. What is a machine? Can somebody define and tell me what a machine is? A machine could be simple like a lever, a screw, a wedge, or it could be complicated like your automobiles. So what is a function of a machine? Can one of you tell me?
Simplify a process.
Yes, simplify a process. You are not able to do something with your hand, and therefore you are going to use some kind of a machine to make your process easy. For example, if you use a lever, you can use the system to remove your nail. With your hand, you cannot remove the nail. You will use the lever to remove the nail. How does it do it? By application of forces and amplifying the forces using your lever principle. So we will use very simple physical principles to achieve our end. So the design process starts with a very simple analysis of the system. Any design process, you should start with you should simplify your design and then try to solve the problem. And step by step, we can include or increase the complication. So in this case, it is very simple. All you need is a lever system here. Again, an axe is also an example of a machine. You cannot cut trees with your hand. An axe helps you. So it is a sort of a machine. A pulley system used in a crane. We cannot lift very heavy weights, but using the crane, we can lift those weights. Okay. So pulley system will amplify the force applied on the load, and therefore we will be able to lift the weight. If the weight is too much, we may use some kind of a hydraulic system to lift the weight. Again, it is an example of a machine. Wheel is also an example of a machine. We'll go to a slightly complicated system. If you take your gearbox, again, this is an example of your machine. What is the function of the gearbox? To be able to vary the speeds. For example, in the automobiles, we will use these gearbox. Design of this gear box is also quite complicated. So let us try to understand, for example, how to design this gearbox. What are the various fields which we will have to be familiar with in order to design this gearbox. You have different parts, for example, shafts, you have gears, you have bearings on which the shaft is supported. The gears are mounted onto the shaft with the help of hubs. Two gears mesh against each other. For example, you have these two bevel gears which mesh against each other and transmit the load at 90 degrees. Okay. In addition, you may require lubrication. From a layman point of view, you will use oil or grease to reduce friction and increase the efficiency of your gearbox system. Okay, so these are the different parts which are involved in the gearbox. So what are the various fields we should understand? You should know something about materials engineering, otherwise you will not be able to select appropriate materials for your different parts. You should know about lubrication or tribology. This is a field which involves lubrication of your system. It studies how lubricants work, and tribology is one of the fields. So somebody should be a specialist in tribology. Somebody needs to be a specialist in stress analysis. Somebody needs to know how to manufacture these gears. Somebody needs to know how the gears work. So he needs to be a specialist in design of gears. He needs to know what type of gears to use appropriately. Somebody also needs to know how the temperature or heat transfer within the system takes place. If the temperature increases too much, again it will lead to damage of your gearbox. So we need an expert, thermal expert as well, who will know how to reduce the temperature of your system. If you take your bearings, again bearings require speciality. Okay, design of bearings is not simple. Again, it needs a person who is an expert in design of bearings and producing these parts. So just looking at this particular system, you will realize that even designing this gearbox is not as simple as it looks. If you take bearings, there are separate industries or companies or organizations working just on bearing, producing these bearings and designing these bearings. If you take gears, again we have specialized manufacturers. If you take shafts, specialized manufacturers. So each part requires specialized manufacturers to produce your entire gearbox. So with respect to us, we will be just utilizing the gears produced by manufacturers, the bearings produced by manufacturers, the shafts produced by manufacturers, and we will be just assembling this part together. Okay, so even when we select parts from different manufacturers, we need to know how to put these things together, and even that is quite complicated. So design is a complicated process even with respect to a machine like this. Okay, so you can imagine how complicated is the design of a automobile, which consists of millions of parts, and one of the part is also gearbox. Okay, so how do we start our design process? So we will start with a very simple block diagram. The block diagram may be as simple as this. For example, you have your machine here, a structure consisting of all the parts put together, your mechanism. Your machine parts may have moving parts or static parts, and all these components can be arranged together. Okay. So we will think of this as a black box. To this black box, we can have some kind of input energy, and there is some output energy. During this process of conversion from input to output energy, there will be always some kind of wastage. Wastage can be in various forms, as heat, as waste products coming through the exhaust, etc. Okay, and the second law of thermodynamics tells us that we cannot convert 100% of the input energy into 100% of the output energy. It will be impossible to do that. Okay, so there will always be wastage of energy. So if you look at the various forms of input energy that has been used in various systems, for example, you can have hydropower plants. You have windmills using wind energy as input, converting it into output electrical energy, solar energy, magnetic. For example, if you take your generators or motors, again we use some electromagnetic system, converting it into output energy. It could be thermal system. If you take your power plants, they use your thermal system. If you take your nuclear power plants, then we use non-fossil fuels to produce thermal energy, then convert it into electrical energy. Hydraulic systems use hydraulics to cause motion. Okay, any lifting of weights, etc. So that could be done using a hydraulic system. Pneumatic system can also be used. Chemical reactions, for example, if you take your IC engines, they use chemical reactions to produce the energy that is required. Your battery uses electrochemical reaction as input, right, to produce the electrical energy. Vibrations can also be used to produce energy. For example, you can convert, for example, if you think about the waves in your sea, convert it into vibrations and then convert that into energy. Gravity, again, if you take your hydro power plants, it's using gravity to produce energy. Dynamic fluids, for example, if you take your propellers used in your airplanes, they are using dynamic fluid motion to produce the output. Biological reaction, your body is a biological machine. It uses biological reactions, chemical reactions to produce energy, and that is output. Okay, so during this conversion here, the output could be in several forms. Again, it could be as motion, as sound, light, radiation. If you take your X-rays, radiation, X-ray machine. It could be in terms of magnetic fields, heating, cooling, electric energy, etc. Okay, so output could be in any form. Wastage is usually in the form of gases, in the form of thermal energy, heat output. It could be in the form of solid, powder as well. For example, if you take your nuclear power plants, you have the radioactive spent fuel, which is present as solid. If you take coal, after you use coal, again, you have waste. So always there is some kind of wastage that is produced. Okay. So when you start your design, you will start with a simple block diagram like this. If you are going to produce a completely new design, this is how you start. And then you start analyzing how to convert from one form to another form. We will see a simple example in this case. So what is design? Design, especially mechanical design, is a process or sequence of steps with a particular goal. Okay, the goal is going to be an objective. The objective might be a single objective. Okay, so for example, I want to remove a piece of nail. It could be a simple objective, or it could be multiple objectives put together. For example, if you are designing an automobile, you have multiple objectives there. The main objective is to move a person from one location to another location using least physical effort and using some kind of a prime mover, for example, using your IC engine or some kind of a power system to move the person from one location to another location as cheaply as possible. So you will have multiple objectives put together in those cases. Whenever you have a design process with certain objectives, you will also have constraints. What are these constraints? The constraints could be cost. Okay, for example, you can invest only this much amount of money. That is a constraint. You have to produce or design of particular geometrical size. For example, the size of the car cannot be beyond certain limit, and you have to ensure your car has a particular size. So that is a size constraint. Constraints could be in terms of loads. What is the total weight the car can transport? So that is a constraint. If you take, for example, elevator in your buildings, again, you will often note that it can carry only 8 to 10% of this much kg weight. So that is a design constraint. Okay. And again, all these constraints, they have to be expressed in terms of values. Okay. So let's analyze each part. So what are the sequence of steps? We will go through these steps in the later slide. For now, we will just go through what is an objective. So the objective could be to, in layman terms, for example, if you take an automobile, to transport a person from one location to another location. Okay. Since the time is up, we will try to discuss this part on objective next class. I will continue from next class regarding this particular part where we will discuss more about the design process, and we will study what is objective and what is constraint in little more detail next class. Okay, any doubt up till this point? Do you guys have any doubt up till this point? So if you don't have any doubt, I'm going to stop right here, and we will meet again on Tuesday at 8 a.m. Okay, so see you guys.